Continue talking about in finding an inverse function today. One thing before we get started is I just want to reiterate the idea about inverse notation, okay? Let's say that f of x represents a function. Then this notation, f, and it looks like f to the negative 1x, but again, it's read f inverse of x, will be used to denote the inverse of f of x, okay? Similarly, this notation to denote the inverse of g of x will be g inverse of x. And again, it's not read g negative 1x, it's read g inverse of x. That's what we use to denote the inverse of a specific function. Even though we see that negative exponent, it does not mean that we're putting the function in the denominator. It doesn't really mean a negative exponent. Notice it's read f inverse of x, g inverse of x. And also, it's not written like this. It's not written like this, like the negative 1 is on the function. That's what tells us that's going to be an inverse, okay? So let's just make sure that we're cautious about the way that our notation is. The placement really does matter, and the way we read it matters as well, okay? What we'll do today is we're going to be looking at how we can find the equation for the inverse function, okay? And what we're going to do is, if necessary, if they give us an f of x or a g of x or some function notation, we'll replace that with y. Then we switch the variables, x and y. We know that that's a property of inverses, is that they're going to be switched. Well, now we're going to isolate our new y. And then we write using inverse notation that we just talked about. Now, if y was given originally, we'll just use f inverse of x, okay? So this says to find the equation for the inverse function. And we have y equals 7x minus 4. Well, let's start by, we already have y, so we can just start by switching the x and the y. X equals 7y minus 4. Well, now let's add 4 to make the, to help isolate our y. And then what we want to do is we want to divide by 7. And you can leave it x plus 4 over 7 since those don't cancel, but oftentimes we can see this is going to be a linear function, and if I were to apply that 7, this would really be 1/7 x. X divided by 7 means 1/7 x. And 4 divided by 7 is like 4/7. And then that equals y. And so now we've done step 3. We've isolated our new y. So finally, we're going to write this in inverse notation. We'll just call this f inverse of x. And then we'll say equals 1/7 x plus 4/7. There we go. All right. Let's try another one. We have f of x equals negative 5x plus 2. Let's replace f of x with y. And now we'll switch the x and the y. And now we can isolate our new y. So we would need to subtract 2. And now divide by negative 5. And so I'm going to think about taking x over negative 5. That would be like negative 1/5 x. And negative 2 over negative 5 would be positive 2/5. These cancel, so that just leaves me with y. And y is isolated. Our original function was f of x, so we'll use f inverse of x. And we'll say that that is negative 1/5 x plus 2/5. Okay, and that's how we find the inverse. It's not bad, right? How about letter C? F of x equals 2/3 x minus 5. Okay, we're going to replace f of x with y. And now switch the variables x and y. And let's isolate our new y. We'll start by adding 5. And now we want to get rid of the 2/3. One strategy when we have a fraction as a coefficient is that we can multiply by the reciprocal. The reciprocal of 2/3 is 3/2. And what happens here is that all of these cancel and I'm just left with y. But then here, just like I distributed each denominator to the denominator to each numerator, I need to distribute this 3/2 to both the x and the 5. Well, 3/2 times x will be 3/2 x. And then 3/2 times 5 is going to be 3 times 5, which is 15, over 2 times 1, which is 2. So plus 15 over 2. Y is isolated. My original function was f of x. So that means that this is f inverse of x, which is 3/2 x plus 15 over 2. Okay? This next one's really fun. You'll see why in a minute. Letter D is g of x equals negative x plus 7. Well, we have g of x. We'll replace that with y. Now we'll switch the x and the y. So I have x equals negative y plus 7. Let's isolate the new y. So I'll subtract 7. And now I want to get rid of the negative. So how would I do that? Well, I'm going to divide everything by negative 1. So x divided by negative 1 is negative x. Negative 7 divided by negative 1 is positive 7. And that equals y. So notice that g inverse of x is negative x plus 7. And what's interesting about that is you guys see that the function and the inverse are equivalent to each other. Interesting. Okay. And then one more example like this, I've got h of x equals negative 3/4 x plus 9. So let's replace h of x with y, switch my x and my y, and let's isolate the new y. So first I'm going to get rid of the 9. X minus 9 equals negative 3/4 y. And once again, we will multiply by the reciprocal. Now, and if there's a negative, again, I'm going to use a negative as well, so that the two negatives will cancel and make a positive. Notice I put the negative in the numerator. It's kind of just bad grammar to have the negative in the denominator. Okay, so the two negatives make a positive, the 4's cancel, the 3's cancel, and here we just have y. Well, here we want to distribute. Negative 4/3 times x is negative 4/3 x. And let's think about negative 4/3 times negative 9. And again, I'd rather you do it off to the side than like get it wrong or guess. And I'd rather you do it to the side than use your calculator. We should be able to do these. So negative 4 times negative 9 is positive 36. 3 times 1 is 3. So 36 over 3 is 12. That's kind of nice. Y is isolated. H of x was our original function, so that means that h inverse of x is negative 4/3 x plus 12. Okay. All right, so those are some examples. Those aren't too bad. Let's just do one more kind of story problem example. In example 3, it says a small company produces greeting cards. The cost C in dollars of producing N greeting cards per month can be modeled by this function. C, I should probably say C of N, but still, C equals 360 plus 0.6N. Okay. And letter A is asking us to find the inverse of the model. Now, one thing I do want to point out is we are not going to switch the variables when we find the inverse of story problems, okay? Let's think about it. Here, C represents cost in dollars and N represents the number of greeting cards. If we mix those up, like legit, we're changing the meaning of each of those variables, okay? So this would be confusing because the letters are chosen to represent real life quantities. So then how would we do that? When we find the inverse of the model, what we're going to do is we're going to keep our variables. Okay. And what we'll do is instead, and we'll isolate basically the other variable. That's going to be our goal here. We had C isolated. Let's isolate N instead. Okay? So don't switch the C in the N. That'd be a bad plan. So we're going to have C equals 360 plus 0.60 N. Now let's think about what 0.60 means. I know we can use our calculators, but I think it's just good to have a conversation about what this really means. 0.60, when we were in school, like when you were little, I don't know what grade, but we didn't read this as 0.60. Maybe your teachers made you read it as what it actually is. This really is 60 hundredths. Okay? So this is really 60 over 100. Remember, this is the 10th spot, the 100th spot. Okay? And let's simplify that fraction. These can cancel, and I end up with 6 over 10. And this can cancel, and that leaves me with 3/5. And I just do that so that I can see that this really is very similar to the other questions that we've had. The 0.6n really could just be written as 3/5. And I'll show you why we might want to do that in just a second. Well, again, my goal is to isolate the n. So first, I would get rid of the 360. And then based on our discussion, we would want to multiply both sides by this reciprocal. So I can get the n by itself. And so these 3's cancel, these 5's cancel, so I just have n. I'm going to use the symmetric property of equality and just move the n over to the left. And now I'm going to take 5/3 times c, which is 5/3 c. And then I can take 5/3 times negative 360. So I'll pull this up real quick. If I take 5/3, this is kind of large, times negative 360. I don't know why I did that. Sorry. So if I take 5/3 times 360, okay, I get 600, and because I was multiplying by a negative 360, oops, wrong screen, I'm going to get minus 600, and n is isolated. We're good. And you might say, well, why wouldn't I just have kept it as 0.6 and divided? Well, the reason is because if I take 5/3 and I look at what that is in the calculator, remember that 5/3 in the calculator is going to be this decimal. And so it's going to be, if I divide by 0.6, that's probably what I should have done. So if I divide by 0.60, okay, that's the same as the 5/3, which is this repeating decimal. We don't want to have that, you guys, okay? So just try to be specific. And that's how we do letter A. So now letter B says, let's use the inverse function to find the number of greeting cards per month in which the company's total cost to produce the cards was $615. So this time we're going to find the number of greeting cards, which is n, and notice that's what's isolated here, when the company's total cost to produce was $615. So this is saying that my C is 615. So I can just do that. I know that my n was 5/3 times C minus 600. And this is saying that my C is that 615. Then we can just substitute that in. We can put that into our calculators, and we see that n is going to be 425. And since it's a problem, a real world problem, I'll put a unit on it as well. Okay? And so that's just a little bit about how we can find the equation of the inverse. So switch the variables except for these story problems, so that way we're preserving the integrity of the meaning of each variable. But then we always isolate that new variable. Okay? All right, have a great day.